Good day, everyone. I am Haishal Libundot, and we are the group 4 that we are going to report about Mann-Whitney U Test. So, what is a Mann-Whitney U Test? Mann-Whitney U Test is the non-parametric alternative to independent sample fit, a statistical test that is utilized to compare two groups where the responses data for the test. Dependent variable is the ordinal or continuous non-normal. Instead of comparing means of the two groups t-test and non-Whitney U test, you can actually compare medians. So we have our examples here. A test for the independent sample tests whether there is a mean difference for both samples. Sample is for the men and women. So, the mean value is calculated and it is tested whether these means values differ significantly. On the other hand, checks whether there is a rank sum difference, so we have to sort them by rank. Mann-Whitney U test is bivariated analysis. Uses two sets of data to be analyzed. Inferential statistics tool for finding significant difference between two sets of data that came from independent samples. Here either one or both of the data are known to be non-normal, not normal distributed. If you want to conduct the parametric independent sample t-test, but your data is not normally distributed or significant, chaperone will test result, or is ordinal by nature. The equivalent non-parametric independent test is the Mann-Whitney U test.
Good day everyone, I am Rensher Gwen V. Tapanas and I will be providing an example for the topic Mann-Whitney U test. So first, we will talk about the t-test. So the t-test for independent sample test whether there is a mean difference for both samples. The mean value is calculated and it is tested whether these mean values differ significantly. So, how to get the mean value? When getting the mean value, it is the average it is found by adding all the numbers and divided the sum into the number of numbers. So, for example, we have a data of 1, 2, 3, and 4. You need to add these numbers and the sum of these numbers will be divided into the number of numbers. Divided into how many numbers? 4. Divided into 4 numbers. So that is our mean value. On the other hand, the Mann-Whitney U test checks whether there is a rank sum difference. So here is the example. In the other set of sample, we have the 11, 13, 1, 10, 12, and 9. That is the data of the other sample, no? And the second sample, we have a data of 5, 7, 8, 13, 4, 2, and 6. So, how to calculate the rank sum? In the illustration shown above, we need to sort all the persons from the smallest to the largest value and add all the rank by group. So, this example will be continued by the next reporter. Thank you.
And now, let's talk about the two hypotheses of Mann-Whitney U test, the null hypothesis and the alternative hypothesis. The null hypothesis is in the two samples that the rank sums do not differ significantly. This means that the ranks assigned to the observations in both groups are similar and any observed differences in the rank sums are due to random variation. On the other hand is the alternative hypothesis. Is in the two samples that the rank sums do differ significantly. To calculate Mann-Whitney U test for two independent samples, we have plotted the values in the table. For one side, we have gender, the female and the male. On the other side, the reaction time, and then assign rank to each values. We will just add up all the ranks from female and all the ranks from male. The rank sums is TB1 equals 2 plus 4 plus 7 plus 9 plus 10 and we get 37. And now we do the same from male. 11 plus 1 plus 3 plus 6 plus 8, and we get 29. And again, the null hypothesis are both ranks are the same.
To expand their explanation, here's an example. Is there a difference between the reaction time of men and women using the Mann-Whitney U test? So, first you need to do is gather the data and arrange them according to their category, which in this case, female and male. And after you do that, you rank them from lowest to highest reaction time. Okay. After you rank them, you need to find the rank of sum of females, which can be found using by adding each rank of female, and the rank of sum of males, which is T sub 2, by adding each of the male ranks. So remember, if two rank sum are the same, then it has a null hypothesis. If otherwise, it is a alternative hypothesis. Find the U value, Z value, and P value. This is what you do. We need to gather the data we solve from the last slide. So we have the T value, the rank sum value of female, which is 37, and the number of cases of females are 6, and the male rank sum is 29, and the number of cases is 5. So first you need to find the Z value. To find the Z value, you need to find the individual values of U value, expected value of the U, and the standard error of U. To find the U value, you need to first find U sub 1 and U sub 2. To find the U sub 1, use this formula and substitute them individually. So the U sub 1 is 14, and for the U sub 2, 16. The U sub 1 and U sub 2 has the same process. The only difference is the rank sum used. For female, you use 37. For male, you use 29. Okay. To find the U value, you need to identify of the two U values. You need to identify the least or the minimum value of U, which is 16, which is 14. So after you find the U value, you need to find the expected value of U. You need to you use this formula and then substitute, and then the standard error of U, this formula, and then substitute. After you find the three U value, expected value of U, and standard error of U, you then substitute it to the formula of Z value, which you will get the negative 0.18 and 25. And after you find the Z value, you will find the P value in your P value table. Thank you.
Good day, sir. For the continuation of our report, I'll be tackling about the versatility with data assumption. Okay, versatility with data assumption in multiple working hypothesis testing, or MWUT, means the method's ability to handle various assumptions about the data distribution or model structure. For instance, in MWUT, you can test multiple hypotheses with different assumptions about the data, like assuming normal distributions, exponential distribution, or non-parametric assumptions. This flexibility ensures a robust analysis regardless of the underlying data assumptions, leading to more reliable conclusions. For example, you're analyzing the effectiveness of different teaching methods on students' performance in a math class. With MWT, you can test multiple hypotheses about how the data is distributed, such as assuming equal variance among groups, unequal variance, or even non-normal distributions. This versatility allows you to explore various data assumptions and choose the most appropriate model for your analysis to more accurate conclusions about the impact of different teaching methods. Another MWT for handling non-normal data to conform more closely to a normal distribution that is are less sensitivity. For instance, in a study examining the marketing strategies on sales revenue, if the sales data is skewed, or MWT could apply a logarithmic transformation to the sales data to approximate normality before conducting hypothesis tests or regressions analysis.
The Mann-Whitney U Test allows us a flexibility for comparing two individual groups and more reliable source or more reliable method in analyzing two groups. MWU test as a statistic tool. Versatility with data. Unlike the popular t-test, the Mann-Whitney U test is a non-parametric test. This means it doesn't require data to follow a specific distribution side or the other. With a outer layer that can significantly affect the means or average used in the data test. So
In dealing with small sample sizes, traditional parameter tests may not be appropriate due to assumptions about the data distribution. However, the Mann-Whitney test does not require the data to be normally distributed. Instead, it ranks both groups' observations and compares their distribution. This makes it suitable for scenarios with small sample sizes or data that does not match the assumption of parametric tests. So as a result, it is frequently utilized in pilot studies or research with limited resources. A Mann-Whitney test compares two independent groups to see if their medians differ significantly. It is useful for comparing effects of two variables, such as comparing the effectiveness of two teaching methods based on scores in exams. The test is reliable even with small sample sizes and non-normal distributed data, making it widely applicable in research. The Mann-Whitney test is used in agribusiness to analyze non-normal distributed data, which is common in agricultural research. It helps to evaluate new technologies and techniques, understand farmer behavior, and optimize resource allocation and management strategies on farms. So basically, it enables researchers and practitioners to make wise decisions based on reliable statistical analysis, especially when dealing with unconventional data. Thank you for watching this video, and I hope you learned something from this.